Okay, welcome back. Welcome back. Welcome back to our tutorial. We're looking at double angles. Let's continue with our double angles. Let's continue, and then we're gonna do a little bit of proofs, and then we're gonna call it a night. All right. So let us say we're being given this question. We're asked to find the exact value of. I'm gonna work on 3 questions here. Let's take sine 75 degrees. We have to find the exact value for sine 75 degrees. Now, remember earlier in our tutorial, we'll talk about sine 75 degrees. We can't readily tell you what the answer is, but I can split 75 degrees into two things that I must and should know. Two angles that I should know the ratios for. All right. And those two angles, remember the angles can either be 45, 30, 60. Combination of all of those. All right. So remember, if I remember, I need two numbers that either when I subtract it, I'm going to get 75 or when I add it. And readily, this comes as an addition to me because I readily think of 45 and 30. So I can use 45 and 30, the sum of 45 and 30 to get my answer. So therefore, I will go ahead and write the sine of the compound angle 45 degrees plus 30 degrees should give me my answer. All right. So just to find out what this thing is now saying. Now remember, when we started off with the sine procedure, the double angle procedure, I did say to you that if I have sine of A plus B, it must give me the sine, started off a sine again, sine A cos B, and the same sign in the bracket comes back out, plus, and I started cos because I started sine first. Now I'm starting cos now. Cos the A sine B. All right. So just to find those little things, those little contractions there. So my aim here is to find if I consider this as A and I consider this as B, it is to find sine 45 degrees multiplied by cos 30 degrees plus cos 45 degrees sine times sine 30 degrees. All right. So once I know those ratios, I can easily well just do what I need to do with that. Now, if in case I falter, I can easily remember my little triangle here. I'm just going to draw a little triangle here. Two little triangles to help me to remember where is what. I know that if this is 45, wherever 45 is, this will be 1, 1, this will be root 2. Remember, these are right angle triangles. And if I have the 30 here, that means that 1 is here, root 3 is here. That means that 2 is here. That means the 60 will be up here. I hope that is clear. All right, so in using now to find out what I need to find out, I can easily just find out these stuff. Remember, I did say to you in the voice note that if you have a 30 at the bottom, 1 is opposite from it, root 3 at the bottom, 2 hypotenuse. 45, 45, it's gonna be the same thing anyway you take it. All right, 45, 45, work with it as is. So here we go. Here we go, here we go, here we go, here we go, here we go. So sine 45 is indeed Sine 45, that is opposite over, what's that? Hypotenuse. So I'll get 1 over root 2. So I'm working on the first part first. 1 over root 2 multiplied by cos 30. Cos 30, if I go to my triangle here, cos 30, is going to put on a pointer here. Cos 30, this is the 30-degree angle here. It will be cos adjacent, which is here, divided by hypotenuse, which is here. So therefore, it will be root 3 over 2. And I'm adding cos 45, I go again. Cos 45, let's go to my pointer. My pointer says cos 45 is adjacent over hypotenuse. So therefore, it will be 1 over root 2 multiplied by, and sine 30. I go to my pointer again, sine 30. Here's 30, sine is opposite over hypotenuse. So therefore, it will be 1 over 2. All right, so I just need to work out this. This is what I'm going to get. Now, because I have the roots in the denominators and it's kind of difficult to actually get work with the roots in denominators, I can rationalize the ratios here. If I rationalize this first part, as I would have told, I multiply top and bottom by root 2. So I'll get root 2 over 2 multiplied by root 3 over 2. And I'm adding, doing the same thing here, root 2 over 2 multiplied by 1 over 2. All right. Can remember that I can multiply underneath the roots. So I get root 6 over 4 here plus root 2 times 1, root 2 over 4. Now I can say 24 goes 24 goes 2 times, 22 goes 1 time. Because remember, this 2 is under the rule of the root. All right, so it's not just 2, it's root 2. All right. So see that the denominator is same here, same digits. I can write it as a single fraction with the entire numerator. So the entire numerator is root 6 plus root 2 all over the single denominator. And that is my answer there. That is my answer there. So let us say you get this question next. Let us say they give you to find tan 75. Okay, right? That's good. All right, let me choose a different number. Tan 50. Without using a calculator. When I multiple is I can get 15. I could have gone 45, 30. I could have gone 60, 45. So down to you which you want to do it. As you can see, the lower the number is more of a subtraction, the higher the number is more of an addition. So if I say 75, it must be more than likely the sum of two things. If I say a low number like 15 or anything below 30, it will be more like the subtraction of two things. So anything above 60, it will be more likely be the sum. Anything up below 15 will more likely be the difference. So because this is below 15, you're looking at a difference compound here. So it's down to me to choose. So if I choose, I may just go tan 45 minus 30. I remember how I would look at this, the tan with the double angle here. If I did the top part is by distribution, and then the bottom is 1, and you change the sign. So therefore, remember, if I have tan A minus B, it will be tan A minus tan B all over 1. The sign in the bracket going to change its opposite here, plus tan A times tan B. All right, so that's the identity for that right there. So it's now to know what is tan 45, what is tan 30. And we'll go back to our little contraction, but we need to first write this out as to what we need to do. So this will be then equal to tan 45. So write out first what we need to do with it with the stuff. Tan 45 minus tan 30. And that is all over 1 plus tan 45 multiplied by tan 30. All right. So here we go. So just remember the tan 45 and tan 30 again. So let us go back to our special triangles that we drew earlier. So it's a tan 45, here's the 45-degree angle here. And we'll put on a pointer here, the 45-degree angle here. The tan 45 will be opposite over adjacent. Opposite, that's tan, right? Tan theta is opposite over adjacent, so it will be 1 over 1. So now tan 45 is 1. We need to find tan 30. Tan 30 would be, here's the 30-degree angle here. Tan 30 is opposite, which is 1 over adjacent, which is 1 over root 3. So tan 45 is 1 over 1. Tan 30, 1 over root 3. All right, so I just carry that information to what I'm being asked to know. Fine. So see, now I know that information. Now tan 45 is 1. And tan 30 is 1 over root 3 over 1 plus tan 45 is 1. Remember, I have to multiply this part of it. So I have to put this in a bracket now that I multiply so that I don't say 1 plus 1 equal 2. All right, I have to ensure that I'm working this part out before I'm adding 1 to it. So it will be 1 multiplied by tan 30 is 1 over root 3. Now we know if we're supposed to find rational, if you have 1 over root 3, I can easily rationalize it so that the denominator is free of radicals, meaning getting rid of the surds. So what would I have to do? Technically, I'll have to multiply the top and bottom by the root of 3. So multiplying both top and bottom by root of 3. Now to rationalize the denominator, 1 times root 3 is root 3. Root 3 times root 3 is, you guessed it, 3. So I can change these out 1 over root 3 as root 3 over 3. So I'm just trying to change this out now. So if I change this out as, and I change this out, so I'll get root 3 over 3, and here I'll get root 3 over 3 as well. All right, so it's just for me to know to work this out now. So I take the top and the bottom, so I can you say that working the numerator. But I need to work out the top part first. So you can put work in the numerator on the exam or step 1 or whatever, work in the numerator or something like that. So let the invigilator know that I'm which part of the question I'm working. So working numerator. So 1 minus root 3 over 3. I can put this over 1. Find the LCM. LCM is 3. 1 into 3, we know that is going to be what? 3 times, right? And multiply the 1 by the 3, we get 3. 3 into 3 goes 1 time. Root 3 times 1, root 3. So we get 3 minus root 3 over 3. So that's what the top part is. All right? That's what the top part is. Now, the denominator now, we can easily multiply this. We know that if anything we multiply by 1, we're going to get the same thing. So this little part here that I have to work first. This little part here that I have to work first. I know that this would be root 3 over 3 because 1 times anything is 1 times whatever number that I'm multiplying, I'm going to get the same thing. So, what do I do then from here? I need to add 1 to it. I can now say working denominator. You will have the space on your answer booklet to work these things. So I'm just trying to make space with the space that I have. So do the opposite 1 plus root 3 over 3. Know that we'll put this over 1. LCM same way. LCM is 3. 1 into 3 goes 3 times. And we already see a pattern developing here. 1 times 3 is 3. 3 into 3 goes 1 time. Root 3 times 1 is root 3. So technically, I'm supposed to divide the numerator by the denominator. So technically, this is what I have. When I work out this now, I would have 3 minus root 3 over 3 divided by 3 plus root 3 over 3. This is really what I need to work out, and that will give me my answer as I go on. So I know that in order for me to work this out, I need to keep the first fraction, change the sign, flip the second fraction. Keep, change, flip. So in keeping, changing, and flipping, what I will then have now, 3 minus root 3 over 3, what's going to happen? Change the sign to multiplication. And instead of saying 3 plus root 3 over 3, it's going to now change to the reverse as 3 over 3 plus root 3. And then I can, cancel, right? I can't cancel the 3 minus root 3 and 3 plus root 3. Can't cancel that. What can I cancel? I can cancel the 3's here. If I cancel the 3's here, 3 into 3 goes 1 time. I then multiply across. So what I then get? I'll then get 3 minus root 3 over 3 plus root 3. And that is my finalmente answer as to how I can find those values without the use of a calculator. If you notice, all I used was just a triangle. All right, so you don't really need a calculator to work these questions out. All right. Next question I'm gonna work one in with pi and see what happens with it. All right, because you guys need to know we need to work it in the radians as well. All right, so here we go to pi. All right, so let's look at this question. We're asked to find the exact value for cos 5 pi over 12. Now, if you guys can convert from radians to degrees very quickly, this would be of beneficial use to you. So I need to first find out, all right, what is this really, what angle is 5 pi over 12, really and true. So I do just a quick conversion. I know that if I'm converting from radian to degrees, I multiply by 180 over pi. So if I have 5 pi over 12 multiplied by 180 over pi, I know the pi's cancel. And then 12 into 180, that's 15. Right? 12 into 180, that's 15. 180 divided by 12, yes, that's 15. And then now multiply now 5 times 15, we know that's 75. So we know that, therefore, the angle is a 75-degree angle, technically, 75 degrees. That's really what I'm trying to find, cosine 75 degrees. Just that the answer is in radian now, and you guys need to know to work in radians. So I need to know, all right, this angle is bigger than 60, so obviously it will have to be, well, not obviously, but see that I know the ones for 30, 45, and 60 out of my head, or you should know it out of your head. What combination is going to give me 75? Combination is going to give me 75 out of 45, 30, and 60 is 45 and 30. 45 and 30. So therefore, I need to know, find out, all right, remember, I know it's going to be 45 plus 30, but I can't write 45 plus 30. Because remember, it's radians I'm dealing with. So I need to know what is 45 degrees and what is 30 degrees in radians. So that means I have to reconvert. So finding 45 and 30 degrees, and what converting degrees to radian, you're multiplying by pi over 180. The pi has to be at the top. All right. So just by a quick check, 45 multiplied by pi over 180. I know that 19 to 180 is 2. You make 2 45s make a 90. So that means that 45 into 180 is 4. So really and truly, 45 is pi over 4. And if I find 30, same thing. 3 into 18 goes 6. The zeros cancel, so it's really pi over 6. So that means that I must be adding pi over 4 to pi over 6 in order to get 5 pi over 12. And that's the procedure that actually be carrying out here. That means that 5 pi over 12 is really pi over 4 plus pi over 6. All right, I have to keep on in the back of my head. All right, 45, 30, 45, 30. That, I have to keep that in the back of my head because remember, I need to know what they're equal to. All right. So here we go now. How do I find this now? Remember with cosine, you group the cosines together and the sines together. Cosines together and the sines together, but the sign in the middle going to change to its opposite. All right, that's the rule. Remember the rule that says that cosine of A plus B is cosine A cosine B. All the cosines are together, but the sign changes to its opposite. Sine A times sine B. All right, so that is what I'm trying to figure out here. So if I choose this as the A and choose this as the B, I will then get cosine A, and you remember this is 45 degrees, this is 45 here, this is my 30 here. So just in the back of my head, I'm keeping that in check. So cosine 45, let's go back to cosine 45 and cosine 30 to find out what is what. So let us go to this slide. Well, this one. So cosine 45, cosine 30, cosine 45, here's the 45 degree angle. Cosine is adjacent over hypotenuse, so we know that's 1 over root 2. Cosine 30 is adjacent over hypotenuse, we know that's root 3 over 2. So cosine 45 is 1 over root 2, or we know 1 over root 2 when rationalized, we give you what? 1 over root 2, you multiply top and bottom by root 2, so you get root 2 over 2. So cosine 45 will then be root 2 over 2, and cosine 30 is root 3 over 2. So I just make the adjustment as I move along. So cosine 45, make the adjustment here. Cosine 45 would be root. I'll have to write out what I'm actually doing here. So cosine pi over 4, cosine pi over 6, minus sine pi over 4 times sine pi over 6. All right. So cosine pi over 4, that is root 2 over 2 by rationalization, multiply by cosine of 30, which is pi over 6, we get root 3 over 2. All right, minus. Now I need to know the sine of 45, the sine of 30. All right, so it's very important as you go in the exams to just nail these two triangles down. All right, so you just keep on reverting back to them. So sine 45 is opposite. Let's put on our marker now. Sine 45 is opposite over hypotenuse. So it's 1 over root 2, and we know it's 1 over root 2 is going to be root 2 over 2. And sine of 30 degrees is 1 over 2. So it's 1 over root 2 for sine 45, root 2 over 2, 1 over 2 for sine 30. So let's go back to our question. Sine 45, that was what again? 1 over root 2, which you know is going to be indeed root 2 over 2, and sine of pi over 6 to sine of 30 is 1 over 2. All right, so just work these things out. Multiply on the square root. I say I can easily multiply because there's nothing there. So the surds there in the denominator, so it's easier to multiply across. So multiplying the surds, I'll have root 6 over 4 minus root 2 times 1, that's root 2 over 4. And see that both of them are common denominators, I can write it as a single fraction in that it will be root 6 minus root 2 over 4. And that is my final answer there. All right, no sweat. What if you got sine, what if you got cosine 105 though? Remember, if it's bigger than 60, what are we going to do with it? Adding. So if I get 105, what combination of 30, 45, or 60 will give you 105? 30, 45, and 60. You guessed it right. So if I have cosine 105, it will then be cosine of the sum of 60 plus 45. And I'll go through the process here. Cosine 60, cosine 45. Sine 60, sine 45. And then go through again. All right, so once you reach into that exam, it's very, very important to nail down that that ratio there. Those ratios. Very, very important to nail them down. All right. All right, let's see if we can prove this identity. We're being given this one. Sine of A plus B over cos A, cos B. And we're being asked to find that that must be equal to or equivalent to tan A plus tan B. All right, very, very simple question. All right, so if you look at it, you remember there's something that was happening at the top. I see a sum of angle, compound angle up here. So I treat it as is, the sum. Expand it out. All right, and this is sine. I start with sine. It will be sine cos plus, because a plus sign in between, cos sine. So I extend the top. So I'll start on the left hand side, so I'll get sine A cos B plus cos A, reverse, cos A, sine B. And that is equal to, well, not equal to, that's over cos A, cos B. So in getting this question now, I have to look to do something with a numerator part now. Can I factorize? No. Because like I can get all the A's together. Because even if we get all the A's together, well, you can't get, because remember that sine A is multiplied to cos B. So you can't break out a sine A and put it beside cos A as a sine A cos A. Alright? Sine A has been multiplied to cos B. So I can't just break it away just so. I can't factorize because there's no common term here. So what can I do? Remember, there's a plus sign in the middle, and it's over a single denominator. The single denominator is cos A cos B. Remember, if there's a product in the denominator, it is over a single denominator. It's saying if I have something over 2x, it's not something over 2 and then something over x, is everything over the same 2x. It's a single denominator. Alright? So this right here, all of this right here is a single denominator. However, I can split this right here and make it over both. I was saying 1 plus, just like I put in the question before, 1 plus 3 all over 2. I'm saying 1 over 2 plus 3 over 2. Same thing. So if I can split this as sine A cos B over cos A cos B plus cos A sine B over cos A cos B. Now what operations can I do to this now? If I try to find the LCM, I'll be going back to what is up here. That's not my aim. My aim is to get it more simpler. So I have to look to say, all right, do I have anything common in these fractions here? Look here, look here, look here, look here, look here, look here. Look here, I have a cos B here and I have a cos B here. I remember there's multiplication going on here, so some things can cancel. This is awesome. Some things can cancel. I can cancel the cos B here and the cos B here. And look over here, so you have a cos A here, cos A here. And I can cancel y because there's a multiplication going on between the terms here. So this is a single term over a single term. So I can cancel the terms that are common. So if I cancel cos B with cos B here, and cancel cos A with cos A as well, what am I going to be left with? Sine A over cos A. Well, look here now. Sine A therefore over cos A, sine over cos is now going to be equal to what now? We guessed it. Tan A. I remember the plus sign comes in the middle. Sine B over cos B. Look at this now. Sine over cos, tan B. Hence, I have proven the identity. That, indeed, the left is equal to the right. So what if they asked us to do something very ingenious with this now? So let us say that they ask us to prove that, and this is actually the actual identity. They ask us to prove that that is equal to that. All right, remember sine 2 theta, 2 sine theta cos theta. So you may be in the exam and you see sine 2 theta and don't remember what on earth to do. Remember, if you have a double angle, if I have 2 theta, or let us say I had 2x, how could I get 2x by an operation? Is that a 2 times x? Well, 2 times x, fine. But what other way that I could have gotten 2x? I could have gotten it by adding x plus x. Remember, x plus x, 2x. 1x plus 1x, give you 2x, right? So theta plus theta must give me sine 2 theta. So I can, even if I forget this, I can work out this in order to find out what the ratio is, what the identity is, sorry. So if I have sine 2 theta, sine 2 theta is really sine of theta plus, not 0, sine of theta plus theta. And I apply. And if I go sine of theta plus theta, remember what to do here? Sum. The sine of theta plus theta, adding compound angles. What should I get? I should get sine of theta cosine of theta plus cosine of theta sine of theta. But remember, look at this now. These two are saying the same thing. So treat this as a variable. This is x, this is x. Sine theta cos theta, sine theta cos theta. So I'll get 2 sine theta cos theta. Hence, that's been proven. All right. Cos 2 theta now. Cos 2 theta actually has 3 identities that you need to know. All right, cos 2 theta can also be represented as cos squared theta minus sine squared theta. All right, so where we have cos squared theta minus sine squared theta, that's cos 2 theta. All right, or it can be 1 minus 2 sine squared theta, or it can be 2 cos squared theta minus 1. So you can have either one of those three. So you'll be looking to see, based on the question that you have to break down, looking to see which one will basically fit the category, fit the bill, as to what is going to help you to simplify your answer faster. So if you have something in cosine already, you know that you'll be going to 2 cos theta, and there's nothing in sine. You know that you'll be going to 2 cos square theta minus 1. If you have something in sine already, and there's no cos theta around it, you can break it down as 1 minus 2 sine square theta. All right. So here we go. Because there's a question that is on the past paper that was worked out yesterday, and you would have to need this identity to help it to work for. So let me go to the question that was given on the past paper yesterday. Let me see if I can bring it up here. Just give me a second, folks. All right, so here's the question. I don't remember which year this was, but here's the question I was actually given yesterday. The question I was given was, and this is a past paper question, by the way. Question I was given was sine theta plus sine 2 theta over 1 plus cos theta plus cos 2 theta. And that should be equivalent to tan theta. How ridiculous. This big fraction equal to that small little something, eh? Then we can tune it. So it goes sometime. So it goes sometime. Now we can just work through this. Remember, we know the identity for sine 2 theta already. So it's very important to just jot down some stuff. Sine 2 theta, remember, look at this. It's 2 sine theta cos theta. All right. Now look at this now. I have the cos 2 theta here. Now remember I gave you 3 of them that we're going to be using. Now at that bottom, it will be unwise of me to introduce. Very unwise of me to introduce sine anywhere there. If I introduce sine somewhere there, it's going to throw up the entire thing because you have 1 plus cos theta already. So you have something in terms of cos theta and without sine theta. So I have to choose the identifier cos for that utilize cos theta or something with cos theta. So the identity that I'll be choosing it to be 2 cos squared theta minus 1. That's the identity. Because remember, it's the only one that has cos theta in it. All right. So here we go. So we have sine theta. Just replacing sine 2 theta now. Plus 2 sine theta cos theta. All right. Looking good so far? Over 1 plus cos theta. I remember I'm replacing the cos 2 theta with this now. Plus 2 cos squared theta minus 1. Very good. If you got that, nail it. 1 mark. So, what can I do here? All right, I see that I have a 1 and a 1 at the bottom. If I group like terms, I'll have 1 minus 1. So I can do that first. At the top, I have sine theta plus 2 sine theta cos theta. Well, look at this. You remember you're looking to the some sort of mathematics with it now. All right, so if you can't add it, you can't subtract it. The next thing you have to do is try to factorize it. Can I factorize that top part? Do I have anything that's common? Yes, I do have something that's common. What I have that's common? I have sine theta as being common. Good. So here we go. Around the ring. Let's continue. Let's continue. So sine theta, if I factor sine theta from the top, I'll have sine theta open bracket. All right, that's the highest common factor. What's going to be the factor inside now? Sine theta? No. 1. Because remember, I have to now divide each of these by the highest common factor. So if I have sine theta divided by sine theta, what would I get? 1. That's my first order of business. And then now I divide all of this now by sine theta. So I factorize by the highest common factor, don't it? Divide the entire term here by the highest common factor. So what's 2 sine theta divided by cos theta? What's going to cancel? Sine theta is going to cancel. So what's it going to be left with? It's going to be left with 2 cos theta. So that's the top part. So bottom part, remember I can bring these two terms together. 1 minus 1 plus cos theta plus 2 cos squared theta. All right, we know that 1 minus 1, that is going to cancel out. 1 minus 1 is always 0. So that is the easiest part of mathematics. See? If add mathematics goes at 1 minus 1, can't get it on the dot. So if you look at the bottom here, remember, if I can't add it, I can't subtract it, what should I look for next? Factorize. So can I factor out anything here? All right, I have a cos and I have a cos squared. I have a cos and a cos squared. So I can factor out cos. Right? So if I factor out cos, I'll have sine theta, just write what's at the top here. 1 plus 2 cos theta. But there's a multiplication going on here. Over, if I factor out the cos theta, I'll have cos theta into cos theta. The term into the highest common factor, I'll get 1. And if I divide the term here by the highest common factor, so 2 cos squared theta divided by cos theta, I'll get 2. It's gonna leave back a cos theta. Wait, hold on. Something is really, really odd here. Look at this. I have now the 1 plus 2 cos theta, both of them at the top and the bottom. So look at this now. If remember, I'm multiplying here, so these are all single terms. Oh, hold on. To the 1 plus. So these are all single, these are multiplications. So I can cancel this here. So I can cancel this here with this. What's it going to leave me with? Because I was multiplying, because when I factorize it, show the process of multiplication, it means that I can therefore cancel. So therefore, what does it leave me with? It leaves me with sine theta over cos theta. And what is sine theta over cos theta, ladies? Tan theta. Hence, I have solved it. So let's say you're given this question. All right. You have to prove that left hand side is equal to the right hand side. I mean, I have a fraction of 1 here, so I just look at the denominator of the second fraction and make a fraction out of it to represent 1. So the fraction I would represent 1 will be 1 plus sine theta over 1 plus sine theta. All right. I'm subtracting cos squared theta over 1 plus sine theta. All right. If the denominators are the same, I don't need to do anything with them. I'll add or subtract them. I just write them back. So the top part will really read 1 plus sine theta minus cos squared theta over 1 plus sine theta. So can't I not transpose or something here? I can transpose for something in sine given cos squared, right? Now everything there in sine, then you just need to just move out the cos squared. So I go to the Pythagorean. The Pythagorean says cos squared theta plus sine squared theta is equal to 1. But look at this now. If I treat it as negative cos, which means that if this cos squared here, should become negative, which means that I'll basically take it and move it. Because if it's positive here, if I move it over here, it's going to be negative, which means that the 1 over here is going to be coming over as well. So if I do a double switch with the 1 and the cos squared theta, the cos squared theta is going to become negative, and the 1 here is going to become negative moving over. So I will actually get I'll actually get sine squared theta minus 1 is really negative cos squared theta. So a positive sine squared theta minus 1 is really negative cos squared theta. What do I have here? I have a negative cos squared theta. So I can replace it with this, which is sine squared theta. So it's just manipulating the Pythagorean stuff there. Manipulating the Pythagorean rule for trig identities. So here we go. So I'm just going to be sine squared theta minus 1 for negative cos. So it will be 1 plus sine theta. And the negative cos now will be a positive sine squared theta minus 1 over 1 plus sine theta. So what can we do now? What can we do with the top? Can I add, subtract, divide, multiply, factorize? You guessed it, I can subtract. Because I have a 1 here, I have a positive 1 here and a negative 1 here. So I can subtract this. So by subtracting, I know that these are going to cancel out. So it's going to leave me with sine theta plus sine squared theta. No, I can't add to get sine cube theta. All right, you can't do that. Math is not done like that. You can't add x plus x squared and get x cubed. All right. Remember that the only way the powers are going to increase is if you multiply, not add. So because I can't add it, I have to look to the best thing next to it, which is to Factorize, factorize. So what can I use to factorize it out? I can use sine theta and factorize. So I'll have sine theta as my highest common factor. But sine theta must can go into each of these, sine theta and sine squared theta. So sine theta into sine theta, I'll get 1 plus sine theta into sine squared theta, I'll get what here? Sine theta. And all of this now is over 1 plus sine theta. What do you notice? If this is my denominator term here, what can I then do? Remember, it's showing by the process of multiplication here. So what can I then do? All of this will be termed as one term, being multiplied by sine theta. So I can cancel this out. So when I cancel it out, what would then be equal to now? It will be equal to sine theta. And that's what I have here. All right, so the final one is coming up next. And then that will be it for tonight. So I've been given this question. So as always, if I have two things working with on the left, one thing on the right, obviously I have to simplify the left is doing back to the right. So this looks a little bit familiar. I have a cos x, of 1 and 1. So how do I find the LCM for this for these two fractions? By multiplying these two terms, right? If I multiply these two terms, what does it look like to you? Cos x. All right, let's try and multiply it. Cos x plus 1 cos x minus 1. I'm sure this looks a little bit familiar. Cos x times cos x, that's cos squared x. Cos x times, well, cos x minus 1, that's negative cos x. 1 times cos x, that's a positive cos x. I know that these two things are going to cancel each other anyway. And 1 times negative 1, negative 1. Just look at the difference of two squares. So you're telling me that if I multiply these two denominators, I'm going to get the difference of two squares. And that's exactly correct. So my LCM is gonna be the difference of two squares. So I'll have cos squared x minus 1. Now I know that if I multiply one by the other, sorry, if I divide one into the one of the denominators into the LCM, I'm going to get the other denominator. All right, so if I divide cos squared x, cos x plus 1 into cos squared x minus 1, I'm going to get the other denominator as cos x minus 1. I remember anything multiplied by 1, you're going to get the same thing. So I'm going to get cos x minus 1 here. Look at this now. Minus in brackets. Now I'm going to have to put what there is. Because remember, I need to know, remember, this part over here is going to be multiplied by the other denominator. All right, and I need to show that is that part going to come here. So the minus sign for here comes back here. And then I'm going to write the answer. So I can just write the answer just like that. So I write the answer in my bracket here that I'm getting. So I have cos x plus 1. All right, so it's just a matter of just removing the bracket now. Cos x minus 1. If I distribute negative to the bracket, I'll have negative cos x. Distribute negative to the positive 1, I'll have negative 1. All right. And then that will give me cos squared x minus 1. Grouping like terms, cos x minus cos x. And cos x is going to cancel. So negative 1 minus 1. Negative 1 minus 1 we know is negative 2. And that is over cos squared x minus 1. No. Remember, my answer has to be in terms of sine squared x. So look at this now. If my answer has to be in terms of sine squared x, I then have to go to the Pythagorean rule. So you know that everything is going to go back to the Pythagorean rule here. So we have cos squared x. But I need to know what is really going to be equal to in order to write it back. Plus sine squared x, and that's equal to 1. Same as theta or any other letter. All right? So I can have cos squared a, sine squared a, cos squared whatever. All right, those have to be x, or so it can be any letter, any value that anything that represents a value. So if I have cos squared x minus 1 here, look at this. For it to be minus 1, it means therefore that this 1 would have to be over here, which means that the positive sine squared x has to be over here. So the positive sine squared x comes over here. What's it going to come over as? Negative sine squared x. So technically, cos squared x minus 1, if the minus 1 comes over, this will have, when it comes over, change sign as well, is equal to a negative sine squared x. So I can change this part out. See, that I know that cos squared x minus 1 is negative sine squared x, I'll get negative 2 over negative sine squared x. I don't know that if I have a negative over a negative, what happens? They cancel. So it's even with 2 over sine squared x, which is what I have here. All right, gentle folks. So it's just a matter of manipulation of the stuff that you have to do, that you have to use to help you to remember the trig ratios. Remember when you go in the exam, nail down the triangle, the special triangle for the special angles. Once you nail that down, you have everything that you need to do compact and done and set out and everything. Just one more, not example, but just a reminder. We looked at this before in class, but just a reminder. If I have, we know that cos squared x minus sine squared x is going to be cos 2x. We know that from the identity, but let us say I have negative cos squared x minus sine squared x. All right. Remember, we looked at this in class. If both of them are negatives, I can factor out the negative. So if I factor the negative, I would have cos squared x. The sign here is going to change to plus sine squared x. So therefore, technically, this is really saying negative of 1, which is negative 1. So this now is equal to negative 1. All right, so a slight variation in the formula can give you a totally different answer. But please do remember, you can see this on the exam where both of them are negatives. If both of them are negatives, you know that that's equal to negative 1. So you just put a bracket around it and put negative 1 underneath here. And just continue and flow with whatever you're saying. All right, so again, cos squared x minus sine squared x plus 2x. The other formula was what? 2 cos squared x minus 1, or 1 minus 2. 1 minus 2 sine squared x. One minus 2 sine squared x, or theta, or whatever other stuff that they give you. All right, so with that, I think we have looked at a lot of identities: cot, secant, cosecant. Remember, try to get everything in terms of sine and cosine. Once you do that, you perform this mathematics with it, and you'll be fine for the exam. All right, have yourselves a wonderful, wonderful night, and all the very best in your exams. All right, you take care.